Hello, everyone. I'm going to do this brief video will be about analyzing experimental data. So we talked about experiments earlier in the course, but we really haven't looked at what experimental data would look like at the end of the day. And some of you may be doing something like this for your project. So I want to show you what it might look like and how you'd analyze it. There's different ways to actually analyze the data and look at it. So this is a file called experimental data. It's up on EduCat now, although we haven't used it in class before. And I'm going to go to the variable view real quick. You can see that there are 4 variables, and really 3 of them were the original variables. I had a group. Well, let me tell you the context of how you might do something, what this might represent before we look at the data. Let's say that a store, maybe Kohl's, decided to do an experiment to see if a training program improved job satisfaction. And so they could go to a single store and they divide up their employees into the treatments and the control group. And the people in the treatment group go through the training. Maybe it takes a couple weeks. You know, it's part of their job. It's not all day, but they go through the training program over time. The control group does not. And so we have a treatment and control, and they measure job satisfaction for both the treatment and the control group before the training program begins, and then again after. So it's a pretty good experimental design, assuming people are randomly put in the treatment and control groups. Not a bad experimental design. And so, we're going to be looking at it. Now, I know obviously a training program usually is not done solely to improve job satisfaction. So they might not be looking at that so much, or they may be looking at job satisfaction in addition to other variables like productivity. But we're going to keep it simple, assuming they're just looking at job satisfaction. So if you look at the data, we have the group number here. And that's just 0 coded if they're in the control group, 1 if they're in the training program, which is the treatment group. Then we have job satisfaction pre-test and post-test. Both are measured on a 1 to 9 numerical scale, very dissatisfied being the 1, 9 being very satisfied, and the respondent can select anything in between those two. Well, any number between those, any whole number, 1, 2, 3, 4, 5, 6, 7, 8, 9. And the same for the post-test. The only other variable here is satisfaction change, and I calculated that. Basically, I'll show you what I did. Compute variable. It's in here. Oh, I'll slow down so you see. If you need to look at a change, you can go to transform compute variable. I already did it, so I'm going to delete what I have in here. I actually did it a couple times, but we're going to do it again. Satisfaction change, and we're going to call this change 2 because I've already done it. I already have a satisfaction change. I'm going to take the post-test satisfaction minus the pre-test satisfaction. Click OK. And you see here it created a satisfaction change 2, which is the same as satisfaction change because they're the same calculations. For our first person here who is in a treatment group, he's in the training program, and had a job satisfaction of 1 originally on the pretest, went up to 5, so it's a change of 4. And you see that in both of these. I'm going to delete the second one because we don't need it, but we see the change here in satisfaction change. In some cases, people's satisfaction actually went down, right? And we can see we go down to the control group, and there's some changes for the people in the control group as well. So kind of the first thing you might look at is not worry about making an inference. Just look at the descriptives. Do we see more of a change in the treatment group versus the control group? That would be kind of interesting. To do that, you can go to Analyze, Descriptive Statistics, and Explore. And I kind of already did it, so I'll redo it. But you put the group under factor. You put satisfaction change as a dependent. And basically, we're using group membership, whether in the treatment group or the control group, to predict what was your change in satisfaction. Okay. And my results, I'm using 2 windows, so I can move my results over here. Kind of interesting to look at. We get to case processing summary, you can see that we have 27 people in the control group, 31 in the treatment group. They're pretty close, but not identical. That's the real world situation. They don't have to be identical sizes. That's something to be aware of. So then we have the descriptives, and we have them, and this is the descriptives for the change in satisfaction between the post-test and the pre-test. So it's the post-test satisfaction minus the pre-test job satisfaction. First, we have it for the control group, and you see the mean is negative 0.222. So what that's saying is for the control group, their job satisfaction actually went down. It didn't go down by that much, but it did actually go down a little bit. And for the treatment group, it actually went up 1.3, which is a little more substantial. It did go up, and obviously there is a difference. If we look at how we calculate the effect of an experiment like this, you take the change in the treatment group, 1.3226, and you subtract from that the change in the control group, which is negative 0.222. And if you do that, you get an actual treatment effect of about 1.5, and it doesn't show us that here, I don't believe, but that's kind of what the end result would be. We'll see it in a minute. All right, so this actually looks, if we were to hypothesize that there's going to be a change like this, that there's going to be, that the treatment group is going to have improved job satisfaction compared to the control group. This seems to support our hypothesis, but again, we've only done this in one store. Let's say it's a Kohl's store. We've only done it in one store. Can we make an inference to the larger population? My guess is we probably can, but we have to actually go and see if that makes sense. So to do that, I'm going to close the output. I hate getting too much output going at once. There's a couple ways to look at this. We'll do the first way, and that's basically a t-test comparing two means. Go to compare means, go to independent sample. And I've already put the stuff in here. I have to change it. The test variable is going to be satisfaction change, because that's really the change between the post-test and the pre-test. And the other thing you got to put in is grouping variable. You select it in there like I just did, select it, and then define groups. This is always tricky. It doesn't really matter how you define it in one sense, but it makes the results hard to interpret if you don't define it correctly. How it does it is it takes group 1 and it basically looks at the change between 1 and 2. And so it's easiest if you make group 1 your treatment group and group 2 your control group. And that's why I have 1 for group 1 and 0 for group 2. Just how the math works. Because you usually expect a change in your treatment group and not much of a change in your control group. And so you want it really to subtract the change in the treatment group. You want to subtract the change in the control group from the treatment group. And if you put in my case, my treatment group was group 1 here in my original data as my group 1, it does the math in a way that's more intuitive. And my control group, which I coded 0, is my group 2. Just trust me on this. So I get the output. We have my group statistics, which is just what I got before. My mean for both the treatment and the control. Again, the mean is just the average change that we saw. And the treatment group is 1.3 change in satisfaction, and the control is negative 0.222. You might say, well, why is it negative in the control group? Well, first of all, that it's not much of a change. It's saying that people's job satisfaction in the control group actually went down between the pre-test and the post-test. Could very well happen. Sometimes people's satisfaction changes. Maybe there was a reason, a more structural reason in the organization, but maybe not. At any rate, it went down. So this we've seen before. Our real test is in the independent sample test here, independent sample t-test, comparing two means. It's a little confusing with the SPSS output. I'll tell you that. There's really two things, two sets of results. Equal variance is assumed, equal variance is not assumed. 99% of the time, it makes no difference which one you look at, and this is one of those cases where it does not matter. The results are almost identical. Why do we have those two? Well, to make a long story short, the equal variance assume means that you're assuming that the variance between the two groups is equal. And the variance that we're talking about is the variance in the satisfaction change variable. So typically the t-test assumes that those variants are about equal. If they're not, it has to do a little different math. Most of the time it doesn't matter. But by variance, we haven't really talked about variance, but a standard deviation is just a square root of variance. So you can think of the standard deviations being equal. If you look at the top, you actually see that they're back in the group statistics. There actually is some difference between the standard deviations between the treatment and the control group. Although it's not huge and probably not enough to worry us, it doesn't really make a difference whether we look at equal variance or unequal variance. I always just look at equal variance. It never really makes a difference, typically. So what we want to look at is a couple of things down here. We want to look at significance, which is 0.003. That's pretty low. That's less than our commonly used alpha of 0.05. So that tells us that the difference that we see is statistically significant. And all that means is the difference we see in the sample is likely true for the entire population. We see a positive difference in the changes. The changes in the treatment group were greater than the changes in the control group. The change in the control group was actually a little bit negative. The changes in the treatment group was very positive, and the mean difference is positive. And we're pretty confident based on our significance test that we'd also find a positive mean difference in the population. It might not be exactly 1.54480, but it would be positive. If we look over our 95% confidence interval, they actually confirmed that too. They're a confidence interval around the difference, the mean difference in the two groups. We see a lower of 0.55966, an upper of 2.52994. All that's saying is that we're 95% confident that the mean difference in the changes that we see in the treatment group and the control group, we got a 1.54480 in the sample. We're 95% confident in the population that mean difference in the changes is somewhere between 0.56 and 2.53 if I do my rounding. So we're still confident there's a positive difference in the population between the group that had the training and the group that didn't, if we were to actually do this on the entire population of all our employees and all our stores. So that's all that means. So yeah, if we hypothesize that the training program would increase job satisfaction, the results do support that hypothesis. So that's pretty much that on analyzing experimental data using a t-test for comparing the means of the treatment and the control group. In this case, the mean change that we saw. The only thing I will also show you is you can also analyze this with regression. And this honestly is the way that I do it. And to do that, I'm going to go to Analyze and Regression Linear. And I already did it, so I have to put my variables out. But basically all you're using is the group variable to predict the change in job satisfaction. And so group is a dummy variable, 0 if they didn't go through the treatment, 1 if they did. And I'm going to run the regression and see, what kind of effect does being in the treatment group have on your satisfaction change. As always, I always want the confidence intervals. Continue. Okay. So we get our results in our regression. We get R square of 0.15, which is not that high. It's saying that about 15% of the variation in the change in job satisfaction is attributed to being in the treatment versus the control group. And so not extremely high, but nevertheless, if we look down at the bottom at our coefficients, we do see that we're going to look at group. And again, if we think of this as a regression equation, that group variable is 0 if they're in the control group, and it's a 1 if they're in the treatment group. We see a coefficient of 1.545. That looks familiar. We get a significance of 0.003. That looks very familiar. And we get a confidence interval, 95% confidence interval with a lower bound of 0.560 and an upper bound of 2.530. All that stuff should look pretty familiar, actually, to what we got with the independent sample t-test. Because they're kind of doing the same thing, is kind of the short answer. Basically, what this is saying is if I'm trying to predict the change in job satisfaction, I'm going to start with my constant of negative 0.222, and I'm going to add to that plus 1.545 times the dummy variable for group membership. All right. So let's think about this. We're predicting their change in job satisfaction from pre-test to post-test. If someone is in the control group, what are we going to predict the changes? Well, we have a constant of negative 0.222. We have a group variable of 1.545. If someone was in the control group, that means we take this coefficient for the group variable and multiply it by 0. So 0 times 1.545 is 0, right? And so we would predict that that person in the control group, the change in their job satisfaction was negative 0.222, which is kind of what we got earlier in our previous calculations. If someone was in the treatment group, we would take our y-intercept, our constant of negative 0.222. We would add to that 1.545, and we would get a positive change of 1.3226, essentially, which is exactly the mean change we got in our treatment group. So in one sense, you can do the regression instead of the t-test, and you come to the exact same conclusion. So two ways to analyze it. I usually use the regression approach, but either way works. So that's it for analyzing experimental data in SPSS.